Imagine an AI system that can scan your files, detect threats, analyze system health, and fix security issues on its own. Not a huge enterprise tool, not a paid software, but something you can and I can build from scratch. Hi everyone, welcome back to the channel. In today's video, I am going to walk through ThreatGuard, my multi-agent AI security system. Built especially for hackathon project, I will show I will show you the architecture, the agents, how it works, and a full demo everything in one place. So ThreatGuard ThreatGuard is an AI-powered multi-agent security framework. It behaves like a smart security assistant that can scan files for threats, detect suspicious patterns, check the system's health, take corrective actions, and generate a final report. All of these is done using a clean modular architecture that can build from scratch. Today's digital world is full of risk, malware, unsafe files, phishing, misconfigured system. Most security tools are too heavy, confusing, or extremely expensive. Students, developers, researchers, we often don't have access to enterprises grade security system. So I wanted to solve a problem. We can create a lightweight, intelligent, and automated security agent that anyone can run on Kaggle, Windows, Linux, or any environment with minimal step. ThreatGuard is my answer to that question. One thing I realized during research is that traditional single script security tools can't handle complex workflows. Threat detection system analyze. Okay. Threat detection system analysis while operations, these need different skill set. So instead of one giant piece of code, I designed multi-agents where each agent behaves like a real security analyst with a defined role. One agent detects threats, one agent suggests actions, one agent executes them, and one orchestrator manages everything, just like a real cybersecurity team. Architecture breakdown. Let me explain the architecture in simple words. The entire code lies inside the source folder, and inside that we have agent folder. So look here, this is the source folder where we have agent folder, memory folder, tools folder, utilities, and main file. So in agents we have action agent, Gemini agent, orchestrator agent, and threat detection agent. Each agent has a single responsibility. In the tools bar, in the tools folder, we have we have tools folder where we have file scanner, file scan, system analyzer, and system hardener. These provide the actual low level work. And then memory folder. And then memory folder. In memory folder, we have memory bank and memory agent. This is memory folder where we have memory agent and memory bank Python file. This allows ThreatGuard to remember past results and maintain context. Util- Utils folder. Now we have utils folder where we have logger file. Logger file. This keeps log clean and structured. And then we have our we have our main file. We have our main file. This is the entry point. It initializes the orchestrator and runs the full security pipeline. Everything is modular, readable, and scalable. You can add more agents later without breaking anything. So Let's see. So live demo walkthrough. Now let me show you the demo. On Kaggle, I used this code to set up the environment and load my API key. Let's see. Here is my Kaggle notebook. So in first part, I have to go to add-ons and add secrets. Add secrets, I have to add my secret API key. This is Google's API key, which I have to add in this. I already have added this API key in my system. In front all of you, I'm going to reset my system. Okay, now draft session waiting for Jupyter. Okay, now I have to run the all the cells. This is this first cell, which is provided by Kaggle notebook. This is no need to run, but I always run this file first. Okay, the system is complete. Now the second, we have to add our Google API key, which we can get from Google AI Studio. And like our assignment, Google's notebook provide the same architecture which I added in this. Now I have to run this file and share. This is run. Now here is mermaid diagram of my ThreatGuard. Here is user admin UI, which is connected to orchestrator agent. Orchestrator connect with log monitor, threat classifier, action agent, and a memory agent, and observability, logging, tracing, and matrices. This is the whole system which connect to each other, and this shows the architecture of ThreatGuard, how it works. Now I have to clone my repository GitHub repo into Kaggle. Here is cloning into ThreatGuard, AI security agent, and finally our repository is cloned. Then I set the path or update it. You can you have to run all the paths here and then see what my file contains. And at the final, we are going to run the project. Here is python /kaggle /working /threat guard hyphen AI security agent source main python. Here I can run it and see the result, what it gives us. The output shows file scan results, threat detection summary, action taken, system health, and finally, the tool generates a JSON report, ThreatGuard run report.json. This is extremely useful for hackathon judges because it provides the system work end to end. Here you can see our Gemini agent working, everything is working here. Demo is running, everything. Here you can see ThreatGuard demo summary, file scan detected, hard-coded password, dangerous API, action taken blocked. It can block all the sites which are malicious for our system and system health at risk. It, it shows that our system is at risk. Now, I just want to show you one more thing. The cloned files the files which I cloned from my GitHub repository, which we can see here on Kaggle working. When you reload it and open this, here is ThreatGuard agent, security agent, and data, everything is here. And when we do it again, ThreatGuard run report JSON. Yeah, here is the report which is developed. And here you can see API, server API, configure, logs, and source. In my this demo, my whole project is run on only source. Here, here is not involvement of these all files. There is no involvement of all these files. So we are okay. So we have to go away. Let me explain how the pipeline flows. First, orchestrator start. Let me show you how everything works. First, orchestrator start. First, orchestrator start. Agent is activated. Then file scan. Here is from agent, Gemini agent. We import Gemini analyst, threat detection agent, agent action agent, memory bank, threat, and file tool explorer, hardening executor. This calls each and every files from our system. Okay. Now I'll show one more thing. Here is our main function, which call orchestrator agent from our system. Now, file scan. It sends your file to the file scanner tool. In step third, threat detection. The threat detection agent analyze patterns and classify threat. System scan. The system analyzer checks system health, CPU disk, insecure settings, risky paths. Action agent. Based on finding, it perform actions, recommended fixes, quarantine a file, suggested hardening steps. At the final report, the orchestrator bundles everything into a clean JSON plus console summary. This pipeline mimics how a real cybersecurity agent works. Now in tech stack, for the project I used Python, Google Gemini API, modular OOP structure, Kaggle notebooks, GitHub repository, JSON reporting, and logging system for debugging. Why Python? Because it's perfect for fast prototyping and has great libraries for security analysis. How to run simple instructions, how to run ThreatGuard on Kaggle. I already show you I already show you demo. You can copy this code. I also add these all the codes in my GitHub repositories readme file. From there you can copy and paste here and do it. Cloning the repository, add your API key to Kaggle secrets, append the src folder to Python path, run main.py. To run it locally, clone repo, install requirements, set Google API key, and run Python src main.py. That's it, no complex setup. If I had more time. Why I'm saying this? Because my semester are on my head, so I can't give more time to this project. That's why I'm going to submit this project before 12 am. So if I had more time, I would add a real malware signature scanning, build a tiny dashboard UI, create a REST API server, and add more specialized agent, expand the system analyzer to detect ransomware patterns, add automatic patch management, build a better memory module for a long-term learning. But even in its current form, ThreatGuard is powerful, clean, and hackathon ready. So one more thing today, here you can see 4 hours, 4 hours, 4 hours, 4 hours, and 5 hours. And for this repository, I create this repositories today again because my past repository on which I work which corrupted. At that repository I was working from 16th of November, but suddenly today that repository got corrupted. So I thanks to God that I already downloaded that file into my system. So I copy all the code from there again. Otherwise, this is not possible to submit this project today, and I have to give it more time. And so that's the full breakthrough of ThreatGuard. my AI powered multi agent security system. If you enjoyed this walkthrough or want to the code, the GitHub link is in the description. If you are participating in the same hackathon, all the best. And if you want tutorials on building real AI agent, make sure to like, comment, and subscribe. Thank you for watching and stay secure. Thank you, guys.